Hi there, my name is Mr. Wagner, and welcome to Wagner Academy as we begin our journey through geometry. We're starting with 1.1 right at the beginning of our textbook with points, lines, and planes. If you're one of my students, you'll find it in your textbook on these pages 6 through 11. If you're not one of my students, hey, welcome. It's fine. Watch these videos. I'm glad you're here and watching. Hopefully you find them helpful. If you want to go back to the home page, there should be a small thumbnail picture of myself there up in the corner, in the upper right hand corner here. Click on that. You can go back to the home page. You can see other videos that I have. You can subscribe there. If you want to print off the notes for yourself, if you're one of my students, you should have a copy already, but if you're not, you can print off the notes for yourselves. I will have a description in the, or a link in the description to this video that you can click on and go to a page where you can print off a PDF version of these notes. If you see any mistakes, please comment in the comments section of this video and tell me what the mistake was and what time you saw it, and I'll be happy to fix that. If you have any encouraging words or if you want to like the video, all those things are greatly appreciated. Please do that if you feel so led, and I will try to be concise with these videos without missing anything. Welcome. Here we go. Let's get started. So generally I'll go to this page and I won't talk about this very long, but for right now, just for a little bit of word on this, of what I'm expecting with this, these are terms, vocabulary and terminology that you should understand by the end of this lesson. So typically I would have you just pause the video here. I would only make this slide last for about 2 or 3 seconds, and I'd go on to the next video, or to the next slide. So just pause if you need to, check these out, and if you don't understand what those terms are by the end of this video, come back to the video and check out, review what you need to. Also, if you're one of my students, make sure you use extra examples in your book for additional help. Another slide I will typically just kind of breeze right through, but just a quick reminder every time. Alright, so let's get started. Geometry 1.1, points, lines, and planes. We're going to start off with some terminology, some things that you just need to know about points, lines, and planes and geometry in general. So fill in the blanks. If you have the notes printed out, this should be very easy. If you want to pause after I'm all done explaining things and then fill it in, that's fine too. If you learn better like that, that's one of the benefits of having it in a video format here. So geometry is what should go in this first blank here. Geometry is the branch of mathematics that deals with the deduction of properties, measurement, and relationships of points, lines, angles, and figures in space from their defining conditions by means of certain assumed properties of space. That's a really fancy way to say that we're going to deal with things like points, lines, angles, figures, different kinds of shapes, in other words, in space. Some of these will be two-dimensional, some three-dimensional, some one-dimensional like lines, and some none-dimensional or no-dimensional like points. And we'll prove things about them, we'll learn things about them, we'll learn properties about them, and we'll use the properties that we know to measure them, to describe different things about them. Moving on, in geometry, point, line, and plane are considered to be, this is going to sound kind of weird at first, I think, but undefined terms. And you might ask, how can something be undefined? So let's think about a dictionary. So undefined terms because they are only explained using examples and descriptions. So if you think about a dictionary, everything in there is defined by another word. So really you have to have an understanding, just an intuitive understanding or basis of knowledge from examples, from descriptions of things like, hey, look at this. This is what we call a point. This is what we call a line. What is a point? Well, we can't really define it formally because we have to start somewhere. We have to have a foundation to start with. So a point we just call a location, or you might say a location in space. So a point is simply a location. Well, what's a location? A location is a point. Well, what's a point? A point's a location. So undefined terms, we have this idea of what a point is, but we can't formally define it. We start with undefined terms, and from there we define new terms based on those undefined terms that we have this idea of. So from there, a line is the next one. A line is made up of points and has no thickness or width. Points on the same line are said to be collinear. If you think of the word coexist, those are things that exist with each other. Collinear is kind of like that same idea. These are points that exist on the same line. And the last one here, you might guess what it is. Our lesson is about points, lines, and planes. This one is a plane. So it's not a plane that flies in the air. This is a different kind of plane. A plane is a flat surface made up of points. Points that lie in the same plane are said to be just like collinear, but with plane, coplanar. And a plane has no depth and extends infinitely in all directions. So you might look at these and say, okay, great, you've written them out in words, but I need to see examples. That's what we're doing next. So here's some examples of points, lines, and planes, and some more information about them. So here's an example of a point. And notice this dot that I drew, it actually has some thickness to it, you could say, but a point formally defined has no actual thickness. It's just this particular location. So I could have drawn that dot super small, but it still doesn't have any size. I could have drawn it a little bigger than that, but in reality it has no size. It's just this specific location. So this is point P. We draw a point as a dot, and we name it with, notice this is a capital letter. So we name it with a capital letter. And some facts down here. A point, we've said this already, but a point has neither shape. So I made it in kind of this circular shape, but it doesn't actually consist of a circle. It's just this location. So it has neither shape nor size. So think of a GPS coordinate. That's a very specific location on the Earth. That's a point, but it doesn't actually have any shape or size to it. And in words or symbols, we would just call this, if we were going to describe that to somebody in a written way, we would say that is point P. And that's it. An example of a line, you're going to have a line connecting any 2 points. And I'm doing this freehand as best as I can. There will be times where I use some of my line tools over here, but right now I don't feel like that's really all that necessary. So I'm going to call this point A, this point B, and this is a line connecting those 2 points. There's actually an infinite number of points in between those points. These are the ones that I drew, though, on the line. And this is a cursive L. We'll talk more about that in a second. So make a cursive L next to that for the line. This is drawn with an arrowhead. Notice we have 2 arrows, so an arrowhead at each end. That signifies that it goes on forever this way, and it goes on forever this way as well. And so this is no dimensions. This is 1 dimension. It goes forever in 1 dimension, this way forever and this way forever. So a 1-dimensional shape here. The letters for this one, next blank, the letters representing the 2 points on the line. That is how we name it. So this could be line AB, or notice this is another way to name it. This is a lowercase script letter. Script, cursive, meaning the same thing. So a lowercase script letter, and there's exactly 1 line through any 2 points. That's an important fact you need to know about lines. Some different ways to describe this line. If you're going to name what it actually is, you could say it's line L. Cursive L there. You could call this line AB. Since I wrote the word line in front of it, this would work. Or an equivalent way to say that would be just writing AB and then writing this little line symbol above it. So it's a miniature line. That's what you see there. So it's got 2 arrowheads on it. You could also equivalently, I can't say the word, equivalently, there we go, call it line BA. Because B to A going forever in both directions is the same thing as A to B going forever in both directions. It describes the same line. So you can say line BA or BA like that. Put the 2 arrows, put the 2 points. Notice these are capital letters, and then if you're using the cursive letter, then that's a lowercase letter. In a plane, for this, you should have an idea what a parallelogram is. And for this, we start off by drawing a pretty typical parallelogram. So this is a plane. This is a two-dimensional shape. It stops here on the picture, but this actually goes forever in all directions. This way, this way, this way, and this way. Imagine an infinite tabletop. That's a plane. So a table that never stopped. That just kept going and going and going. That would be a plane. And I'm going to draw 3 points that are not on the same line, non-collinear points here. I'm going to call those X, Y, and Z. And then in the corner of the plane, I'm going to use a capital cursive P to label this plane. And this is typically shaded, so I'll use yellow to shade this in. You can shade this in lightly on yours as well. You'll see it shaded in our textbook. If you're one of my students, you'll see planes shaded. So as a shaded, slanted, four-sided figure. That is typically how, or that is how we'll draw planes. And a capital script letter is a way you can name a plane. Or by the letters naming, and notice, remember I said these were non-collinear points. So these are not on the same line, so you can use 3 non-collinear points. And there is exactly one plane through any 3 non-collinear points. Different ways we could name this plane. You could use that script letter and call it plane, and then write a cursive P in this case. So P is not a point on this plane, P is the plane. X, Y, and Z are points on the plane. So you could call this plane X, Y, Z. Now you might ask, would plane Z, Y, X be another valid way to say that? Sure. Just use any of those 3 points, or use those 3 points in any order, and you're good to go. So let's write that underneath there, or any other order. Of those 3 letters. So moving on to some examples from here. So let's check out some examples where we actually use what we just learned there in our terminology. So a line containing point K. What's in this picture? We're using the figure to name each of the following. So what is the name of a line containing point K? We have some options here. If you were one of my students taking a test, you wouldn't have to name all these options unless I told you to name all the options. You could just pick one of these. So I look at this line. It's got a cursive L right here. That's one way I could name that line. So this could be line L. A second option, I could say this is line AK. I'm going to just use the 2 letters and then write the little line symbol above that. So you could say that, or remember, you can flip the order of those letters. Is there more? Are there more? Sure, because we have point S also on that line. So we could use S and K if we wanted to. We could say line SK. Or equivalently, switch those around, you can say line KS. And a fourth option, we used A and K together, we used S and K together. We could also use A and S together. So we have line AS. Or line SA. So that's 4 valid ways to name the same line. Now, part B, a plane containing point A. So point A, remember, you have to use, if I go back to this slide, it's one plane through any 3 non-collinear points. And so I cannot just say plane ASK, because these are collinear points. I have to use 3 non-collinear points. So let's write down our options. I'm going to name them all here. One option, we can use that cursive capital script letter in the corner. This could be plane W. A second option, we could say let's pick 3 of these letters, but remember you can't use A, S, and K. You can use 2 of those, but not all 3 of those. They can't be on the same line. So we could say plane, and we don't have a symbol like we do for line for plane, so we just have to say plane. And we could say K, A, T, or any combination of those 3 letters. So you could say T-A-K or A-K-T instead of K-A-T, but those 3 letters. That's one way to name it. Plane. So I use K-A and T. I could use S-A and T. These are non-collinear points that lie on that plane. So S-A-T. Perhaps a test you'll be taking soon. I don't know. Hope you do well on it if that is the case. And plane. So I've used these 3. I've used these 3. I could use these 3, a combination of those 3 as well. And I'll go with T-S-K. The order could be different. The order could be different of S-A-T and K-A-T. But these are my 4 possibilities. And remember, with these 3, you can switch the order of the letters around. So let's make a note, though, as to why we couldn't use A-S-K, because this is a common mistake that I see students making. So you cannot say plane A-S-K because the points must be non-collinear. Non-collinear meaning not on the same line. And why that is, you could actually draw, don't draw this in your picture. This is just something I want you to watch. But you could have another plane going through ASK like that. So this doesn't describe, if you said plane ASK, it doesn't describe a unique plane. It describes just one plane of many possibilities. Or it describes, I guess, a better way to say that is that there's an infinite number of planes that go through A, S, and K. I could have another plane drawn in like that. Still goes through A, S, and K. So don't draw those in. That's just to show, to make a point. There we go. All right. To make a point. Funny. You're funny, Mr. Wagner. Anyways, moving on. Sometimes I'll crack bad jokes. You just laugh for me, okay? Thanks. Draw and label a figure for each relationship. Line GE and line OM intersect at T for G at -2, 3, E at 4, 1, O at 4, 4, and M at -2, 0 on a coordinate plane. So a coordinate plane, notice, two-dimensional shape that extends forever in both directions, or in all directions, I mean. This is a coordinate plane. I've drawn the grid lines in here to make it easier to graph. Let's graph these points. So -2, 3, we should go back 2 and up 3. That's going to be point G right there. Point E is at 4, 1, so go right 4 and up 1. Here's point E. O is at 4, 4. Go right 4, up 4. There's point O. And M at -2, 0. So here's -2, 0 right there. So I've got my straight line tool here. And you could use a ruler. That would be helpful. I'm going to go keep that in blue. And I'm connecting these with a straight line. That arrowhead's not very big, so I'm going to make that a little bigger. And then we do the same thing for GE. So I'll connect G, going through E, going to extend this out a little bit more. Right, so it's extended a little better now, and we've got the arrowheads there. So let's finish reading this. Points R and Y are coplanar with these points, but neither are collinear with either line. So we should label T first of all, so that's where they intersect. So this point right here looks like it's at 1, 2. That's point T. And then if I draw points R and Y, these could be a lot of different places as long as they're not on the same line. So they're coplanar, so they're on the coordinate plane, because that's our plane that we're talking about, but they just don't lie on either of these lines. So I could say, if I wanted to, R could be down here. This is just one option. I could say that Y is up here, another option. Y could be right here, it could be right here, it could be right here. But it couldn't be right here because that's right on the line, it's collinear. And we're saying these are not collinear with either line. So let's make a quick note about R and Y. Do they have to be in those two particular places that I drew in there? No. You can say that R and Y could be anywhere. Let me be a little more specific about that. So they could be anywhere as long as they aren't on the lines. And for part B, this is a separate example within the example here, but a similar type of example. Line RK lies on plane P and contains point A. So I'm going to draw a plane. Remember, it's a parallelogram type shape. So it's a four-sided figure, and we're drawing it on a slant. And this is plane P, so I'm going to put a cursive capital P in the corner, and it contains point A. So line RK contains point A. So I know since it contains point A, all 3 points have to be on the same line. All 3 points would have to be collinear. So here's a line. I could call this R and K, and since point A is on that line, it contains point A. That could be A. Did A have to be here? No, it could have been in between them. Could have been on the right side of it, but it still had to be on the same line. And notice I tried to spell some things here just for fun. If you put these letters together, it's geometry with a missing E. We're not going to double up on the E, but we have geometry there, and park, I spelled out park there. A couple of my favorite parks in the world. You should go there if you ever get the chance. Yosemite and Glacier National Park, right here in the good old US of A. Beautiful, beautiful places. And our last slide here, our last page, this is another term we should know. So space. What is space? It's the final frontier. Space is a boundless, three-dimensional set of all points. So we had a plane that was dealing with just 2 dimensions, x and y. You think of the coordinate plane, x is 1 dimension, y is the other dimension, the other direction. Now we're talking 3 dimensions. The world that we live in, we typically think of as being 3-dimensional, although there are some physicists out there that might argue that there's more dimensions in the universe than that. Ooh, crazy, blowing your mind. But 3 dimensions, we're going to stick with 3 dimensions. Use the figure below to complete the following. So how many planes appear in this figure? How many planes do you see? Let's write them out. So I see clearly this is a plane right here, the green part. I could call that plane W, or I could call it plane, I got to use 3 non-collinear points, remember. It looks like A, G, and N are non-collinear, and they lie on this plane, plane W. So I could call this plane A, G, N. Now you could call it N-A-G or G-A-N. You could use any combination of those 3 letters, remember. That would also be valid. Or equivalently, plane W. That's the same plane. This greenish plane could be described in either way right there. Now you have some other planes here. You have this face of this triangular pyramid. So A, G, and R would describe another plane. So plane A, G, R. And again, you can switch the order of those letters if you wanted to. You could say plane rag. You could say plane gar. You could say plane, what other combination? RGA. Something like that. The right side of this triangular pyramid, I could use any of these 3 points. However, I can't use R, E, and N because they're collinear. So I could pick any 3 non-collinear points of those 4 points. why don't I go with O, G, R, and N. And again, you can switch the order of those letters. And a final plane that I see on this figure, I see 4 planes. I see the green plane, the front of this pyramid, the right side, and kind of this back side here of the pyramid. This is A, R, and N. So that would be the last plane that I see there. 3 points that are collinear, that are on the same line. Looks like only R, E, and N are on the same line. So I would just go with those 3 points. And again, you could write those in any order as long as you get all 3. Notice I'm naming points here and not a plane, so I just use one letter at a time. So point R, point E, point N. And then finally a point that is not coplanar with A, N, and G. So here's A, N, and G. That's on the green plane, and the only points that aren't on that green plane are E and R. So you could say either one of those points. You could say E, or you could say R. So that'll do it for this lesson for us. This is 1.1. Go back, pause, and rewind as needed to review anything that you missed or didn't get. Feel free to write in the comments section if you saw any mistakes, had any questions, or had any encouragement for me. Hope you have a great day, and I'll see you for 1.2.